Hello friends, welcome back to my channel. I'm Mr. Suen Chutke. Today guiding you with chemical reactions. Now chemical reactions is an extension of chemical changes. Now changes are always of two types. One is a physical change and the other one is a chemical change. So what is a physical change? Physical change is the one in which there is no change in the chemical formula. Now what do you mean by that? Say for example, I heat water and water converts into water vapor. So even when it was water, the molecular formula or the chemical formula was H2O, and even after it is converted into a gas, still the molecular formula or the chemical formula remains as H2O. So there is no change in the chemical formula as such. So this cannot be called as a chemical change. It is a physical change. So chemical change can take place only when there is a change in the chemical formula. Okay, so let us see, for example, conversion of milk to curd. Yes, so this is a chemical change. Conversion of an rusting of an iron tawa. This is also a chemical change, Fe to Fe2O3. Then formation of wine from grapes. So this is also a chemical change. The glucose in it has been converted into alcohol or ethanol. Cooking of food, my dear friends, is also a chemical change. There is change in the chemical formula. This food you eat, you are digesting that food. The digestion of the food is involving reaction of enzymes, acid, etc. All that is involving a lot of biochemical reactions, and hence this is also a chemical change. Then we are respiring, we are taking in oxygen and giving out carbon dioxide. So this oxygen is also helping us to metabolize glucose. Okay, so that is also a chemical change. Okay, then in all the above situations, the nature and identity of the initial substance have somewhat changed. Hence, all of them are chemical changes. Now, when we are having these chemical reactions, okay, I want you to study in this part, but this particular part of the video, types of chemical reactions. Now, let us see which are the different types of chemical reactions. Before we move ahead, let's do a small activity, right? So let us take a pair of tongs, okay, and a magnesium ribbon, and let me light up the Bunsen burner. Okay, Bunsen burner is lit up, and let us start heating this magnesium on this Bunsen burner. You will observe that this magnesium starts burning with intense heat and light. Okay, it starts burning with intense heat and light because Mg is reacting with the atmospheric oxygen. Mg plus O2 gives 2 MgO, and when it is reacting, it is converting into MgO, which is falling over here as white powder. So that is MgO. So what have you observed? You have observed that magnesium was burning with a dazzling white flame, which turns into a white powder, and that is magnesium oxide. Okay, now let us take another example. Like here we are having a test tube and we have kept lead nitrate solution and potassium iodide. Let me take, with the help of a dropper, potassium iodide and add it to lead nitrate solution. Now, when I'm adding drops of lead nitrate to this, you can see that there is a color change over here. A chemical reaction is taking place. Now, can you tell me what is the chemical reaction that is taking place over here? So it is potassium iodide, that is Ki, okay, Ki plus lead nitrate, that is PbNO3 twice, yeah, 2Ki plus PbNO3 twice will give you 2KNO3 plus PbI2. So this PbI2 is giving you a yellow color here. So this is how a chemical change is taking place. Okay, now you can observe that in the previous case there was an accompaniment of what? Accompaniment of dazzling light. See, the reaction is accompanied with dazzling light in case of magnesium. In the previous reaction wherein we saw Ki and PbNO3 reacting, there was a change of color. So some reactions are accompanied with a change in color, some reactions are giving out light, some reactions are giving out heat, some reactions are evolving a gas. Now let us take a few zinc granules. Okay, here we have taken some few zinc granules and put it in the conical flask. Here we are having dilute H2SO4. This dilute H2SO4, with the help of a dropper, let me just pour it into the conical flask. So as I'm pouring this dilute H2SO4 into the conical flask, you will be able to see that this dilute H2SO4 is reacting with zinc granules to form hydrogen gas. So this reaction is evolving what? Hydrogen gas, right? Zn plus H2SO4 gives us ZnSO4 plus hydrogen gas. Okay, so some reactions are proceeding with evolution of gas. They are accompanied with evolution of gas. Now, hydrogen gas is, how do you identify that hydrogen gas is only released over here? You can identify that hydrogen gas is only released over here by using something called as a glowing splinter. Glowing splinter, if you insert in the hydrogen gas hydrogen environment, and because hydrogen is a non-supporter of combustion, it will get extinguished. Okay, and if you are using a burning splinter and you are allowing hydrogen and oxygen to react, the hydrogen will burn with a pop sound, right? Hydrogen will burn with a pop sound. Yeah, so some reactions are proceeding with change of state, that is evolution of gases. Now whatever we have seen up till now, in some reactions there was change in state, in some reactions there was change in color, in some reactions there was evolution of gas, in some reactions there was change in temperature, and in some reactions there was formation of precipitate. Okay, so now we are having like solids converting. Change of state is what? Solid converting into gas, or maybe solid converting into liquid. You all know this, right? Solid converting into liquid is melting, liquid converting into solid is freezing, solid converting into gas is sublimation, and gas converting into solid is deposition, or liquid converting into gas is vaporization, and gas converting into liquid is condensation. Okay, so this is involving in some reactions, that is change of state is there in some reactions. Some reactions are involving change of color. Ripening of fruits is also a chemical change. A chemical reaction is taking place and there is a change in color. Some reactions are involving evolution of gases. Okay, and some reactions are involving change in temperature. Okay, some of them are involving change in temperature. Okay, and some of them are involving like change in temperature is also of two types, like endothermic and exothermic, absorbing heat and releasing heat. Absorbing heat endothermic, releasing heat exothermic. Formation of precipitate, some reactions do form precipitates. Then have a look at this valency chart, have a quick look, right? So this is hydroxide, chloride, bromide, iodide, all of them are having a valency of -1. Okay, then -1 or +1, all of them here are having a valency of -2 or +2. Okay, then there are some elements with dual valency like copper, Cu+1, Cu+2, Fe +2 and +3. Okay, and aluminum is having a valency of +3, NH4 is having a valency of +1. Then chemical equations. So the first equation which we had done, burning of magnesium in presence of oxygen, Mg plus O2 gives MgO. Now this is your LHS, this is your RHS, both need to be equal in order to satisfy the law of conservation of mass. Okay, law of conservation of mass states that mass can neither be created nor be destroyed. It can only be converted from one form to the other form. And anyway, this is a, you can say, word equation. What is this? This is a word equation. Okay, and in some we can convert this word equation to a chemical equation. Instead of writing the full word magnesium, we can write Mg plus O2 gives 2MgO. Okay, so this is a molecular chemical equation. We have not yet balanced it. So for balancing it, we know that there are two oxygens on the left hand side, there is only one oxygen on the right hand side. So in order to make this 2, we'll write a 2 over here so that it becomes balanced. Okay, so we'll write a 2 over here and 2 over here. Now Mg becomes 2, so I'll have to write 2 over here. 2Mg plus O2 gives 2MgO. Now what are the other things which are present in a reaction? This arrow is indicating the reaction is moving in the on the forward direction, and a reverse arrow will indicate that the reaction is moving from products to reactants. Okay, and whatever is written on the arrow is the information. Okay, whether it is heat or what, heat, temperature, pressure, all those things. A plus sign indicates that there are two reactants. A plus sign over here will indicate that there are two products. And LHS and RHS, like in mathematical equation, you are having LHS and RHS, and in between you are having equal to sign. Here we are not having the equal to sign. In place of the equal to sign, we are having the arrow. Okay, and the physical states are mentioned over here in brackets: S, G, S meaning solid, G meaning gas. Okay, an upward arrow will indicate that a gas is being evolved. A downward arrow will indicate that a precipitate is being formed. A broken arrow will indicate that the reaction is moving in both the directions. So what is the broken arrow? Broken arrow will look like this. See, broken arrow, meaning that the reaction is reversible. It will move towards the product side as well as towards the reactant side. Yeah, now balancing of chemical equations. Now how do you balance chemical equations? That we are going to see in the following part of our video.